Continuous probability distribution. Not all data is discrete. For example, continuous random variables, which are of type interval ratio or scale. Taking example, if x is the variable, for example, x is height in centimeters, then small x is the value of individuals for x. For example, one person can have a height of 170.5, another can be 150.0, another can be 180.0. All of these values can be described using a probability density function, which is easiest to understand when you look at it as a chart. Now, to understand, this is not particularly new to us because what we're doing here is this is just a frequency. This is the frequency diagram that we've seen before. So the PDF, the numbers on the left-hand side, the y-axis, that's just frequencies, and the numbers along the bottom are the actual x values. So 170.5 will be one of those points along the blue line, 150 will be another point, and 180 will be another point. And the PDF, the densities at the left-hand side, the y-axis, that's just frequencies. So you can see that there that there's a lot of data around the middle and there's less data around the edges. Now the example I just showed you of height, the distribution of height data, is a typical normal distribution. Normal distributions have specific properties which are useful and they're also very common. In a normal distribution, the data is distributed symmetrically around the mean. So you've got this nice smooth hill with both sides being equal. The mean is equal to the median, which is equal to the mode, which is that center blue vertical dashed line. And it's obviously a standard hill in that you have it's denser and taller in the center and less dense in the tail. So most of the data is in the middle and there's very little data out on the edges. For the normal distribution, the area under the curve is 1. That's true for every distribution, in fact. All of the data, 100% or 1, is underneath the curve. But specifically for the normal distribution, 68% of the data is typically inside one standard deviation, that is above and below. So that area in the middle from the center out to one standard deviation below and one standard deviation above makes up 68% or nearly two-thirds or slightly over two-thirds of the data. 95% of the data is inside 2 standard deviations from the center, and you can see that on the chart. And then if you want to get even more, you can say that 99.7% of the data is inside 3 standard deviations. And there's often then still a tiny little bit of data which is outside of those boundaries. And these are empirical rules. Reminder that the area, probability density function, the area under the curve is equal to 1 or 100%.